Hello, everybody. GL1 here, and welcome to another Toy Talk about dinosaurs. But this one's going to be a little bit different and a little bit scientific. Sometimes my friends and clients ask me, GL1, where do you get your ideas from? And really, a lot of times it just stems from sitting there, while I'm watching TV or something, and I have some toys on a shelf, or on just somewhere around, and I stare at them, and I just come up with ideas. And this is one of those times where I was looking at the figures and pondering them, and I have. This is the new Allosaurus, the Evolution Allosaurus, which we did a show on, and it's got the button you push and the spikes come up. And that's, not exactly what inspired me to come up with this show. But what did initially was one of the reviews that first came out about this toy was how the teeth were individual. And I thought, yeah, they are. That's kind of cool. It's not like just one big slab of plastic with the teeth growing out of it. But then I thought, I think I have seen older ones that also have individual teeth. And so I went to my inventory of T-Rexes and other dinosaurs, and I saw that this one from 2015, already 9 years later, the chomping T-Rex has individual teeth. And I can't believe that I've had this thing for 9 years. Well, one of the things about this T-Rex is that it falls over all the time. It's very difficult to get to stay up. I have taken the legs and put them in boiling water and tried to bend them so that it will stand up a little bit better. And so that's why it's standing as well as it does. Still precarious, however. One of the problems with this figure is that the feet are not to scale. And that's one of the things I'm going to be talking about today. So I had these two figures facing each other, and I was looking at how the Allosaurus is longer and, in a way, just a larger dinosaur in this case than the T-Rex. So you could assume, well, maybe this is just a juvenile T-Rex. But I was noticing that the head, even though the Allosaurus was longer, so you can see here, the Allosaur is about an inch longer in this case. Actually, maybe it's not so easy for you to see. Let's see if I can line them up here. I line up the heads, and then you can see the tail's about an inch longer on the Allosaur, maybe an inch and a half. But I was looking at that, and I noticed that the head, though, on the T-Rex is far more massive. And, T-Rex did have a massive head for crunching bone. And I thought, well, even if T-Rex were smaller like this with that head, it would definitely be more formidable, its bite force and everything. But then I got to thinking, is it to scale? So I looked up in several different places the size of a T-Rex head and the scale of that to its body, and the same thing with Allosaurus. And what I found is that a T-Rex head is 1/8 of its body, whereas an Allosaurus should be 1/10. So the head of an Allosaurus should be about 3 feet long, and the body's about 30 feet. And the T-Rex's head, and we're measuring from about right here, right where the neck connects, okay? I think they have a foramen magnum, I believe is what it's called, where the neck connects into the skull. So that would be 5 feet on a 40-foot body, so that's 1/8. Well, so I got out a measuring tape, and I started measuring and found out that these two dinosaurs are not to scale. So you can measure the head here. So it's about, let's say in this case, it's 8 centimeters, the head, and the entire length of the body is 42 centimeters. So if it was 8 times 8, it should be 64. So he should be 64 centimeters long, but because he's only 42, it is definitely not the right scale. So in this case, the head is 5 1/4. The scale is 1 to 5 1/4. So that's way off. So that's just unrealistic. And then I went and I measured the Allosaurus head here. And we can, let's see, straighten the tail out. And get about let's say about 6 centimeters. Okay, so maybe about right here. And if we measure the length and we say it's about 43 centimeters, then it is a 1:7 ratio, not the 1:10. So that's the wrong scale there. So this is not, so you could say, well, maybe the head is correct in comparison to the legs and the torso, but the tail might be too short. And that tends to be the truth of a lot of these action figures. So then I started to suspect, maybe all of them are off, or I can measure some of these other Jurassic World toys and find out which ones are correct or close to correct. So then I took out this T-Rex, okay? So you'll recognize, if you're a collector of these, this one's different. You push the head down and the jaw opens. And I think this one came with the Jurassic Park vehicle. I think it was that combo pack. But all right, so then I went and I, measured this one. And so we say the head's 7 centimeters and the body is 49. So still not quite the right scale. That's a 1:7 ratio, but we're close to the 1:8 ratio. So it's close enough that maybe a T-Rex is 1:7. Now, human beings generally range from in the 6s, 1:6 ratio, head to body height, the head height to the body height, up to 8. So actually a lot of tall, like supermodels, have really long legs, and they are a 1/8 ratio, whereas a lot of people, well, the Greeks felt the ideal is like 1:7. That's, like they thought that is, maybe the average. It's not, I don't think it's necessarily the average. I think it's somewhere in the high 6s or something, like 1:6.5 or something like that ratio. But anyhow, so this is possibly correct, but it's still not the 1:8 ratio. So then I said, well, let me get the big, this is the big scale T-Rex. That's the toy one, not Hammond Collection. And I thought, well, let's take this fella here. This is like a thrash and throw version. So he would, bite, and he's got his tail. He's got one button that thrashes with the tail. You see that? You push a button, and then you push this button, and he can kind of throw with his mouth. Supposed to bite, I believe. Chomp and bite or something. Yeah, there, he's kind of, I guess he's going to bite you over here and then throw you that way. All right. Well, anyhow, so let's measure this guy here. And he's got those ratchet legs. Always feels like you're going to break them. But let's measure him and get the ratios. So we're going to measure the head, and that's about 8.5 centimeters. And then the overall length, accounting for a little bit of the curve in the tail. So we're going to say it's 56, right? So, and that's a 6.6 ratio. So is it that the head is too large or that the tail is too short? Not sure, but the smaller T-Rex actually is more accurate on this. So, all right. So then I thought, well, are any of the T-Rexes accurate? Well, that's going to be the cliffhanger. I'm going to make you wait. We're going to go back to the Allosaurs and find out if we can find an Allosaur that is the 1/10 ratio. So we go to the Allosaurus that came out before our Evolution one. This is the guy that gets the boo-boo in the side. Put that panel in, and oh no, his ribs, and then something can then bite into the ribs and lift them up and get to the soft, gushy center of our Allosaurus. Poor Allosaurus. All right, well, Allosaurus's head here we'll measure is about 7 centimeters. So, and we have a curve in the tail. So we're going to say it's about 48 centimeters. So that's about a 6.8 ratio, 6.86, somewhere in there. So not quite correct. Again, we really need to get to 1/10. I mean, even 1/9 might be pretty accurate. So what is it? Is the tail not long enough? From the drawings, that's what it looks like. Though this is a really long tail, it probably even needs to be longer. And if you look at lizards, they can have really, really long tails. So it is a reptile. So perhaps that's the where they're missing it. They also might be making the head bigger just, for effect. Well, so I went to the other Allosaurus toy, some of the ones from a few years ago, and we said, well, let's take a look at their ratios here, and then we can measure the head there, and it's about, let's say about 5.5 centimeters, and then the length, and we're going to go, let's see, 25, and then we have this curve, 25, we're going to go 30, and then maybe another couple, 30, 32. Okay, so let's do that. And that comes out to 6.4. So again, far away from the needed 10. And even if it was, if I missed a couple of centimeters, it's still not close to 10, 1/10. So, all right, so then I thought, well, this is another Allosaur that came out a few years. Actually, this, I believe, came out before that one, just slightly. So let's see how this measures. It's a little bit different head shape. So this one has a 4 centimeter head, and the body is about 33, maybe with the curve. Let's say 34. Let's be generous. So let's do that ratio. And again, we end up with a 6.8 ratio, 7. So this is more like a human being, right? So if upright, this is from tail, it's kind of the human representation of scale. All right, well, is anything going to be correct? Well, let's not wait any longer. Let's check the Hammond Collection T-Rex. All right, so the Hammond Collection T-Rex, the gold standard in design of dinosaur toys. So let's see how this measures out, and we'll measure that here now. And we have, let's see, so the head is 8 centimeters, and the entire length is 64. So 8 times 8 is 64. So this T-Rex is exactly the ratio that it should be. How about that? So if you want to ever make a T-Rex toy or anything, a statue, this can be your standard. It is the gold standard in T-Rex accuracy. And we can take a look at that and compare that to our first T-Rex. So if you look at the head, so the heads aren't that dissimilar in size, but you can see how much shorter it is. So the head maybe is about a centimeter shorter, but you can see the tail is quite a bit shorter. It's a good, I was going to say at least 20 centimeters. It's 23 centimeters shorter. So that makes a big difference. Well, then I thought to myself, let's go and check to see if the juvenile Hammond Collection T-Rex is accurate. Now, juvenile children, human children, have a different ratio. Their heads are large in comparison to their body. So perhaps that's true on a T-Rex. So it might be it might be off a lot, it might be off a little. It'll be interesting to find out. And so the head there is 2.5 centimeters, and the entire length is about 17.5. So what we get is exactly 7. So we get a ratio of 1 to 7, which that is, the ideal Greek proportion for a person. And it might actually be pretty accurate for a T-Rex because it's supposed to be 1/8. So being that it's juvenile, it also has a little bit of a curve in the neck. It's not all the way forward. That could account for some of the loss. So this might be closer, would be closer to 1/8 than a little. So it's got to be more than 1/7 because of that curve difference in the neck. But in any case, the Hammond Collection juvenile is also very close to accurate. So, and that length you can see, it's in the tail. So then I thought, well, is there another easy to find the statistics on dinosaur? And I thought perhaps Triceratops. So the Triceratops, this is a Hammond Collection Triceratops. My biggest complaint with the Hammond Collection Triceratops is that this is too small. It should be about 30 feet long, so it should be closer. Let's say if it were here with the T-Rex, it probably should come out to about there, and it should be taller as well. So Triceratops was larger. So this would not be a full-size Triceratops. But the head should be, the head's 5 feet. 10 feet. And the body is 30, so it's 1/3. So they are measuring from the crest to the horns. So that's about 8.5 centimeters. And then the body length, and I use centimeters because it's easier to get all the little measurements in. All right, and it's about 30 centimeters. So we're looking at, 30 divided by 8.5. So that's a 1 to 3.5 ratio, which is close to 1 to 3. And that actually might be more accurate. There's going to be variations on the crests on these animals, and even the horn length and everything. So it's in the right range. So I would say this too represents a rather accurate model of a Triceratops scale. And then I said, well, let's look at the new Triceratops, the Evolution Triceratops. And I like this one because in terms of, it's still not long enough, but it is bigger. And to me, it's getting closer to being the size that the T-Rex would have to contend with. All right, well, let's measure this guy here. So let's see, that head's, we're close to like 9.5 centimeters. And then the body length, again, this is 33 centimeters. So let's check that. So we are again at about 3.5. So once again, they've managed to have a pretty accurate Triceratops scale. So that's great. So you could also think, play with this with confidence that it's the right scale. So we're definitely very close. So the other thing is the T-Rex feet. Now, the T-Rex footprint is only about 1.5 feet long because they walk more on their toes, not flat like this. And so this helps it to stand better. But actually, our first T-Rex, you see how it has its foot elevated and it's kind of walking on the ball of its feet. That would be a more accurate footprint for the T-Rex. So the actual length, though, of the whole foot is about 1 meter, so it's about 3.3 feet. So if we measure this here, we're looking at 10 centimeters. So the foot should be 1/12. So 10 centimeters, and what did we say for the length here? So it's 64. So that's a 1 to 6.4 ratio, right? So that's not accurate at all, and that helps it stand better. So let's take a look at our T-Rex that falls down really easily and see if the foot on that is actually more accurate in terms of its body length. So if we measure that, it's going to be about 4.5 centimeters. And so dividing its length, about 44 centimeters by 4.5, we get 9.8 ratio, 1 to 9.8. So that's actually a more accurate foot length for the T-Rex. All right. Well, I hope you enjoyed that. I hope you learned something. And, you could always take your Jurassic World toys or other toys, dinosaur toys, and try to look up lengths of heads and body length and figure out the ratios. You're just going to take the length of the dinosaur and divide that by the length of the head, and then you'll get your ratio, and you can see how that matches up with the real world measurements of their skeletons. All right, well, thanks for watching. I hope you enjoyed that and learned something. I did, and I look forward to talking to you again real soon.